Good afternoon. I'm Miss Mike Sullen. I'm one of the chemistry teachers at Eagle Crest, and today's podcast is the virtual lab for the 1 gram of salt lab that we are doing in class. If you were absent, hopefully this lab will help you get a data set and familiarize yourself with the actual lab procedure. We have two different essential questions for this lab. How can we use stoichiometry to determine the amount of reactant needed to produce exactly 1 gram of sodium chloride? And how can we calculate percent error and percent yield using our theoretical calculation and our experimental data and analyze for sources of error? Our EQ in today's lab is pretty wordy. Please make sure that when you're writing your claim, you're fully answering all parts of the EQ. So your claim will need to address the amount of baking soda needed to produce exactly 1 gram of sodium chloride. It will also need to cite your theoretical yield as well as your experimental yield, your percent yield and percent error, and whether or not your percent error was valid. If you were invalid, you will need to do an error analysis, explaining possible sources of error and how those sources affected your experimental yield. So take a moment and hit pause and answer the background questions, please. All right, question 1 asked you to write a balanced chemical equation with states of matter for the reaction between solid baking soda, sodium hydrogen carbonate, and excess hydrochloric acid, HCl, that produces sodium chloride, water, and carbon dioxide gas. I'm not going to go over that balanced chemical equation because that is one of the things we're assessing you on in this lab. If we look at question 2, look at your products in the reaction above. What do we isolate, or how will we isolate the sodium chloride from the other two products so that we can measure it at the end of the lab? Well, the sodium chloride is going to be with water and carbon dioxide gas. It'll be very easy to get rid of the carbon dioxide gas because we can just perform this experiment in an open system so that it will bubble away. To get rid of the water, we'll simply need to use a hot plate or a lab oven to evaporate it. So we'll let the carbon dioxide bubble off in an open system, and we'll evaporate the water using either a hot plate or a drying oven. Using the balanced chemical equation in states of matter, predict the two visible ways in which you know the reaction is over, that all of the baking soda has reacted. Well, since the lab is producing a gas, one of the first ways we'll know that the reaction has completed is if we see the bubbling and fizzing stop. No more gas produced. The second way is that we shouldn't see any solid white powder, any baking soda visible in the beaker at the end of the reaction. So take a moment and pause this video and use stoichiometry train tracks to determine how much baking soda, sodium hydrogen carbonate, do you need if your goal is to produce exactly 1.00 grams of sodium chloride. All right, the procedure for today's lab is pretty short and sweet. You're going to use a Sharpie to record your group's identification on the beaker, as you will not be able to collect your beaker until the next class. Then you'll need to mass the empty beaker and record the mass. Measure out the calculated amount of baking soda from your stoichiometry and add it to your beaker. And then add hydrochloric acid to the beaker, drop by drop, until all of the baking soda has been dissolved and is no longer visible as a white solid. Hand your beaker to your teacher to either place on a hot plate or in a drying oven to evaporate off the liquid water. And once the water has evaporated off, mass the beaker and the sodium chloride product that remains. You'll need to record just a couple of measurements in your data table: the mass of your empty beaker and the mass of your beaker with the product after you've evaporated off the water. From those two numbers, you should be able to calculate the mass of just the product. So let's take a second and get a virtual data set. We're going to start by massing the empty beaker. In your lab sheet, please record the mass of the empty beaker, 29.48 grams. And then I'm going to put a weigh boat on the scale and zero it, so the weigh boat is no longer accounted for, and add in the calculated mass of baking soda that your stoichiometry tells you to react in the lab. Purposely I'm obscuring what the scale says because your job in this lab is to determine how much baking soda you need to react. So we're not going to tell you the number that we're measuring into that right now. But that measurement you'd get from your stoichiometry. Then we're going to take that plastic weigh boat and we're going to add our baking soda to the beaker that we already massed out because we're going to do the reaction in that beaker. So we need to just kind of carefully pour all of the baking soda into the beaker and tap the weigh boat several times to make sure that all the baking soda gets in there. Want to make sure that all of the measured reactant that you used, you're actually getting into the beaker. And now we're simply going to fully react it. So we're going to add hydrochloric acid drop by drop until all of the baking soda has reacted. Remember, from the pre-lab, we'll know all the baking soda has reacted when we no longer see vigorous bubbling when the acid is added, and when all of the white solid powder in our beaker is no longer visible. We see clear evidence that there's still baking soda, that large white circle in the bottom of the beaker, so our reaction is definitely not complete yet. Getting closer though, there's very little baking soda left. I can just see a little bit of bubbling right in the center in that tiny little white dot. Just a small amount remaining. You may notice I have a procedural error there. I spilled some of the solution. How will this affect the amount of product I recover? Will that make my percent error positive or negative? I may need to write an error analysis. All right, now we're going to just take some time to evaporate off the water so that we can measure the solid product at the end. And as you can see, it's crystallized into what looks like kitchen salt. Nice, pretty white crystals of sodium chloride, solid in the beaker. So our last step is to get that final mass. And we can see our final mass is 30.46 grams. Please note that an error analysis should state your percent error and identify the procedural cause of the error and the impact to measured data. For example, if I was doing an error analysis on my data from this lab, I might state my percent error was -2%. That means that I am under the true results by 2%. I spilled some of the solution onto the counter as I swirled it into the beaker, which means that I will not recover all of the product at the end of this experiment. My experimental yield would have a lower mass than it should. Will the beaker on the left over here have a percent yield that's positive or negative? The beauty of this lab is that when we look at our beakers at the end of our experiment, we can usually very visibly see the errors that occurred and predict accurately how they'll affect our data and our calculated values. I can look at this group's beaker and know with certainty that they reacted it really quickly, and they might have overflowed the container as they reacted it with acid at the beginning of the experiment, likely losing some of their product and giving them a negative percent error. Hope this was helpful. Please complete the lab and get it turned in to your teacher. Have a great day.